Varda Space Industries recently achieved a milestone in space exploration with the historic return of its in-space manufacturing capsule, leading to a captivating display of photography capturing the event. The culmination of Varda's W1 mission occurred on Wednesday, February 21st, as the capsule containing crystals of the antiviral medication ritonavir, grown in orbit, successfully landed and was recovered. Ritonavir, a valuable drug used in treating HIV and hepatitis C, benefits from the microgravity environment of low Earth orbit, which allows for the formation of more perfect structures, as highlighted by Varda. The California-based startup aims to spearhead the utilization of orbital manufacturing spacecraft to forge innovative pathways for engineering materials in space. Leveraging microgravity conditions, inaccessible through terrestrial processing, presents unparalleled opportunities for material processing, as emphasized on the company's website. Varda's successful recovery marks a significant achievement, positioning it as only the third private entity, following SpaceX and Boeing, to retrieve an intact spacecraft from orbit. The W1 capsule embarked on its journey in June 2023, hitching a ride aboard SpaceX's Transporter 8 rideshare mission, and spent over 7 months in space, accompanied by a Rocket Lab Photon spacecraft that provided essential support in terms of power, propulsion, and navigation. Following retrieval, Varda plans to transport the capsule to its headquarters in Los Angeles for thorough post-mission analysis. Moreover, the antiviral drug will undergo further study in a pharmaceutical laboratory. Notably, data collected throughout the capsule's flight, including segments reaching hypersonic speeds, will be shared with the Air Force and NASA under contractual agreements. In addition to striking photographs capturing the event, Varda's CEO and co-founder, Will Brewy, shared a video from aboard the W1 capsule showcasing Rocket Lab's Photon spacecraft descending to Earth after the capsule's separation for its return journey. The successful landing and recovery of Varda's W1 spacecraft mark another significant achievement in the Utah training and test range, following NASA's recovery of a capsule containing samples from the near-Earth asteroid Bennu in September 2023, collected by the agency's OSIRIS-RX mission. ERS was designed in the 90s, and we are making much more progress today, Flora said. But the technology was not available when ERS was designed. The imminent re-entry of a non-operational European satellite serves as a stark reminder of the risks associated with existing space debris. Despite ongoing efforts by agencies to curb its proliferation, the European Space Agency's ESA, European Remote Sensing ERS-2 satellite, which had been in orbit for close to 20 years, was projected to re-enter the Earth's atmosphere on February 21st. ESA's latest update on February 20th pinpointed the re-entry time at 11:32 a.m. Eastern Time, with a margin of error of approximately plus or minus 4.61 hours. Launched in 1995, the ERS-2 satellite, weighing nearly 2,300 kilograms, was designed to gather Earth science data using advanced instruments, including a radar altimeter and a synthetic aperture radar (SAR) mapper. However, despite its operational shutdown in 2011, the satellite lacked the necessary propellant for a controlled re-entry. Mako Albani, manager of Heritage Space Programs and Missions at ESA's Earth Observation Program, revealed at a briefing on February 13 that certain components of ERS-2 were expected to survive re-entry, such as 4 fuel tanks and internal panels. Notably, the SAR antenna, weighing 52 kilograms, was anticipated to be the largest surviving component. Despite these projections, ESA did not provide a quantification of the risks associated with potential falling debris from this specific re-entry. Albani reassured that none of the debris from ERS-2 contained toxic or radioactive materials. When ESA made the decision to terminate ERS-2 operations in 2011, efforts were made to lower the satellite's orbit from 785 to 573 kilometers using the remaining propellant. Subsequently, onboard systems like batteries were deactivated to prevent the possibility of a debris-generating explosion. However, due to design constraints and insufficient propellant, further descent was unattainable, as highlighted by Tim Flora, director of ESA's Space Debris Office. ERS-2 adhered to earlier debris mitigation guidelines mandating satellites to be deorbited within 25 years of the end of their operational life. Nevertheless, ESA introduced a new orbital debris mitigation policy in November, aiming to significantly shorten the post-mission disposal timeframe to just 5 years, among other measures. In alignment with ISA's zero debris vision, Francesca Letizia, an engineer specializing in space debris mitigation and re-entry safety at ESA, emphasized the ongoing implementation of the new policy, acknowledging that full adoption would take time. She described it as a journey that had just commenced and would evolve progressively throughout the decade. While the new policy primarily targeted future missions, its applicability to existing spacecraft in orbit was not universal. Albani explained that a Space Debris Mitigation Assessment Board would evaluate the application of the new rules on a case-by-case basis for older missions. Looking ahead, ESA aimed to achieve zero debris for future missions by the 2030s. The formulation of the new policy drew from the lessons learned from past mission failures. Notably, the malfunction of ERS-1 in 2000 and the subsequent stranding of the satellite at an altitude of nearly 800 kilometers underscored the challenges posed by space debris. Similarly, the malfunction of the Envisat mission in 2011, leaving the 8-ton satellite stranded in orbit, further highlighted the urgency of addressing space debris accumulation. Scientists have recently discovered the brightest and most voracious black hole ever observed, situated in the distant reaches of the universe. This extraordinary object, identified as a quasar, illuminates from the powerful core of a galaxy, fueled by an immense black hole approximately 17 billion times the mass of our Sun named J0529-4351. Its remarkable luminosity was confirmed through observations conducted by the Very Large Telescope in Chile. Detailed in the journal Nature Astronomy, researchers reveal that this black hole exhibits an insatiable appetite, devouring matter equivalent to the mass of one sun each day. While data recording J0529-4351 dates back several years, its true nature has only recently been recognized. Christian Wolfe of the Australian National University explains that despite its brilliance persisting for millennia, the object was initially mistaken for one of the numerous stars within our Milky Way. Quasars like J0529-4351 represent an energetic category of galaxies known as active galactic nuclei, AGN, characterized by the intense activity emanating from a supermassive black hole drawing matter at an extraordinary pace. As material spirals into the black hole, it undergoes acceleration, generating immense luminosity visible even from vast distances like that of J0529-4351, situated billions of light-years away. The emissions from this quasar, having traveled an astonishing 12 billion years to reach our detectors, highlight its astronomical significance. Notably, its consumption rate of 1 solar mass per day stands as a testament to its extraordinary luminosity, equivalent to over 500 trillion suns. Rachel Webster of the University of Melbourne emphasizes the uniqueness of this quasar's rapid mass consumption, underscoring its profound luminosity. Furthermore, the sheer size of the hot accretion disk emitting such intense light, spanning 7 light-years in diameter, astounds researchers, highlighting its colossal scale. The presence of supermassive black holes at the cores of galaxies appears to be intrinsic to their evolution, suggesting a fundamental role in shaping galactic structures. Samuel Lai, a co-author of the study, notes the pivotal role these black holes play in the formation and development of galaxies, indicating that without them, the universe's galactic landscape would be vastly different. The puzzle surrounding the rapid growth of such massive black holes early in the universe's history prompts scientists to explore scenarios wherein these objects may have emerged directly from the primordial gas existing post-Big Bang, possibly preceding the formation of the first stars. This ongoing investigation offers valuable insights into the fundamental processes governing cosmic evolution. The Sun recently unleashed its most potent solar flare in about 7 years, marking a significant event amidst an explosive week of solar activity. This X6.3 class solar flare, the most powerful of the ongoing solar cycle designated as Solar Cycle 25, peaked in the afternoon on Thursday, February 22. According to the National Oceanic and Atmospheric Administration, NOAA, it was the third solar flare within a span of 24 hours emanating from an active solar region labeled as AR 3590. Preceding this remarkable event, an X1.8 class flare erupted from the same sunspot region on Wednesday, February 21, followed by an X1.7 class flare on the early hours of Thursday. despite the intensity of these flares. Neither of the preceding two was accompanied by significant coronal mass ejections, CMEs, as reported by the European Space Agency, ESA. While powerful solar flares like these can potentially disrupt communications and power infrastructure on Earth, no CMEs were observed accompanying the X6.3 flare. Although the previous flares seemed to coincide with widespread cellular outages reported across the US, ATT attributed the outage to a software issue, according to Reuters. NOAA cautioned that the X6.3 flare could lead to temporary degradation and signal loss for high-frequency radio users on the sunlit side of Earth. However, the agency assured that the general public need not be overly concerned about this particular flare. ESA noted that AR-3590 would soon be directly aligned with Earth, anticipating further flares from this active region in the days ahead. The agency estimated a 15% probability of another strong X-class flare and high probabilities of more moderate C and M-class flares within the next 24 hours, as AR-3590 rotates toward Earth. The possibility of geomagnetic disturbances increases, particularly if subsequent flares are accompanied by CMEs. The exact impact of these events depends on factors such as the speed and trajectory of ejected solar plasma. With the active region becoming increasingly magnetically connected to Earth, energetic solar particles following magnetic field lines may affect Earth and orbiting satellites. NASA classifies X-class flares as the most powerful among solar eruptions, with each successive class on the flare scale, similar to the Richter scale for earthquakes, increasing by a factor of 10. Thus, X-class flares like this recent one possess significant energy release potential, underscoring the Sun's heightened activity as it approaches solar maximum, the peak phase of its 11-year cycle anticipated to occur around 2024. This period heralds increased sunspot frequency, active regions like AR-3590, and heightened solar outbursts. Intuitive Machine's Odysseus lander achieved a historic feat by softly landing near the lunar South Pole, marking the first private spacecraft to do so on the Moon. This groundbreaking event on February 22 is significant, as it's the first gentle landing by an American vehicle since NASA's Apollo 17 mission in 1972. NASA Administrator Bill Nelson praised the achievement, highlighting its importance for humanity's progress in space exploration. The success of Odysseus reflects the renewed focus on lunar exploration under the Artemis program initiated by former President Donald Trump in 2017. Artemis aims to establish a sustainable human presence on the Moon by the late 2020s, laying the groundwork for future missions to Mars. Integral to this effort is the Commercial Lunar Payload Services (CLPS) program, engaging companies like Intuitive Machines to facilitate scientific exploration and support a lunar economy. Odysseus began its journey to the Moon aboard a SpaceX Falcon 9 rocket on February 15, carrying 12 payloads for studying the lunar surface. Despite encountering challenges during descent, including issues with laser rangefinders, the Odysseus team successfully patched the software, enabling a smooth landing near the Malapert A crater. Mission Director Tim Crane expressed relief as Odysseus confirmed its presence on the lunar surface, initiating its operational phase. Over the next 7 Earth days, Odysseus and its payloads will conduct scientific investigations to enhance our understanding of the Moon. Although Odysseus landed on its side due to a faster-than-expected descent, its solar panels remain functional, ensuring continued communication with the team. Most payloads, except Jeff Koons' Moon Phases sculptures, are on the upturned side. The team plans to deploy the EagleCam to capture images of the lander and its surroundings. Issues with the laser rangefinders were attributed to human error, but a last-minute adjustment using onboard NASA payloads facilitated a successful descent. Despite the unexpected landing orientation, Odysseus mission represents a significant advancement in private space exploration, contributing valuable insights for future lunar endeavors. NASA's upcoming Ultraviolet Explorer (UVEX) mission, slated for launch in 2030, marks a significant stride in our quest to comprehend the mysteries of the ultraviolet universe. Selected as NASA's next astrophysics medium-class explorer mission, UVEX aims to deepen our insight into the evolution of galaxies and stars, equipped with cutting-edge technology. UVEX will conduct a comprehensive all-sky survey in ultraviolet light, offering fresh perspectives on the dynamic processes governing celestial bodies. Its swift pointing capability will enable rapid capture of intense cosmic phenomena, including the aftermath of gravitational wave-emitting events such as neutron star mergers. The mission's arsenal includes an ultraviolet spectrograph tailored for the scrutiny of massive stars and stellar explosions. Nicola Fox, Associate Administrator of NASA's Science Mission Directorate, anticipates that UVEX will revolutionize our comprehension of both nearby and distant galaxies, as well as provide crucial insights into the evolving cosmos. UVEX's observations, complemented by concurrent missions like the European Space Agency's Euclid and NASA's Nancy Grace Roman Space Telescope, will contribute to constructing a comprehensive map of the universe across various wavelengths of light. Mark Clampin, Director of NASA's Astrophysics Division, underscores the mission's pivotal role in studying transient phenomena, addressing a fundamental priority in contemporary astrophysics, despite a 2-year delay in its launch. Attributed to budgetary constraints, UVEX remains poised to embark on its primary 2-year mission. Fiona Harrison, an astronomer from the California Institute of Technology, will lead the mission's scientific endeavors, supported by partners from the University of California at Berkeley, Northrop Grumman, and the Space Dynamics Laboratory. With an estimated cost of approximately $300 million, excluding launch expenses, UVEX epitomizes NASA's commitment to facilitating cost-effective access to space through the Explorers program, a cornerstone initiative dedicated to advancing space science investigations led by principal investigators.